Hello everyone and welcome to another episode of the Power Logic. And it has been a while since the last video, and this problem is from the this year's AMC 10B number 22. So it's asking a group of 16 people will be partitioned into 4 indistinguishable 4-person committees, and each committee will choose 1 chairperson and 1 secretary, and find the number of different ways and written it as 3 to the r times m, where m is not divisible by 3. So what is r? So first, let's try to write the expression of finding the total number of such ways to choose it. So first we're gonna form the committee first, and then try to choose 1 chairperson and 1 secretary from that. So there are a total of so you can choose 4 people from the 16 people first, and then choose 4 from there, and then continuously, so that you will form 4 committees of 4 people. But then there's a caveat that this will have some overcounting, in a sense that, for example, if I choose A, B, C, D first, and then I choose E, F, G, H the second, this is actually the same choice as choosing E, F, G, H first and then A, B, C, D second. So this means that from this total number of choices, we have overcounted by a factor of 4 factorial, which represents the distinct way to, like, the distinct order of choosing these 4 committees. So this means that we have to divide by 1 over 4 factorial times this. So this is the number of ways you can choose the committees, like partition the committees. But then now you have to multiply by the number of ways you can choose 1 chairperson, 1 secretary for each of these committees, which there will be a total of 4, which will be 4 times 3 to the 4, right? Since here what we're doing is we're basically just we have to choose for each of the committees we have to choose 1 chairperson first, which has 4 ways, and then you choose the secretary, which has 3 ways, from the 4 people that excluded the person that you have already chosen. So yep. So now the only part that we have to do is we have to find the maximum power of 3 that can divide 16 choose 4, 12 choose 4, 8 choose 4, and 4 choose 4, and then we are done with this problem. So now let's take a look. So first, we can notice that 4 factorial will have the maximum power that 4 factorial can divide by 3 is going to be 1, since 4 factorial has only 1 factor of 3, which is 3, right? So basically, we just have to look at how many factor of 3 are there in 16 times 15 times 14 times 13, and then subtract it by 1, and then we'll get our answer, right? So now notice that here the only factor of 3 would be 15. So this means that 16 choose 4 will not be divisible by 3. Now let's look at 12 choose 4. Well, let me now 12 choose 4. Well, we have 2 factor of 3. No, we have 1 factor of 3 in 12 and 2 factor of 3 in 9. But then we have to subtract it by 1. So this means that 12 choose 4 is in fact divisible by 3 squared, which is 9. So this means that it's going to contribute 2 factor of 3 to the entire maximum power that divides 3. So now 8 choose 4, the same idea, 8 times 7 times 6 times 5 over 4 factorial, and then the only factor of 3 comes from 6. So this means that 8 choose 4, which we can even compute it out to be 70, is not going to be divisible by 3. And 4 choose 4 is obviously not divisible by 3 because it's 1. So this means that the entire part, 16 choose 4 times 12 choose 4 times 8 choose 4 times 4 choose 4, that's only going to be divisible by 9. So there's only going to be 2 factor of 3 there. Now 4 times 3 to the 4th, then this will contribute 4 factors of 3. And 1 over 4 factorial will contribute, will actually take away 1 factor of 3. So this means that our final answer will just be -1 plus 2 plus 4, which is going to be 5. And that is our final answer. So thank you for watching, and I will catch you in the next video. Bye bye.